more time. That looks good. Oh, wait a minute. That's not right. That's not the right one. Back to the meeting. Come on. Go back. Close this out. Let me stop the share. Let me share again. And I like this one better. Share. Okay. All right. I don't think we have anybody in the waiting room. That looks good. And let me load the chat. I need that to kick over. That always takes a little bit of time to boot up. So while we give the equipment a little bit of time to warm up, so I think some really good questions were raised. One question for this class was about the grade, and essentially you're only responsible for all the stuff that's in Pearson, right? So the grade that you see in Pearson, that's what I'm going to pull. I'm just going to use it as my baseline. I'll probably just show your scores, probably like homework, quiz, exams, and final. Right, that's what I'll probably report over. But the grade is basically based on what's in Pearson. So what I see there, that's what I'm gonna use. Let me see. Sometimes I can do this. That helps it. What was the other question? Oh, and then there was another question about late assignments and like getting credit for things turned in late. So I think across the board, I did like a 10% late penalty for everybody, right? All my classes. But again, what that means is if you really want an A on any assignment, you can still earn it. Like you would just have to get a perfect score. If you get anything less than a perfect score, then it'll be like a high B or whatever it is. But if you really want an A, you can get like a 90 because it's only a 10% late penalty. And I've had students do that. Like they just maxed everything out and they were able to keep it moving. I was like, okay, that's fine with me. I'm just trying to get this to kick over, and then we'll get the party started. Let me see if I do this. If this helps. Let me give this some power too, because I know that'll try to die on me at the worst time. Okay, that's looking better. Okay. Let me see. So this is section, we're going to be closing out section 2.3. This is week 11. So we can be on the lookout for exam 3 sometime next week, more than likely on Wednesday. We'll probably take on Tuesday, we'll probably use Tuesday as a review to just kind of review chapter 2. And then Thursday, the exam usually is available on that Wednesday at midnight. Let me see. Okay. Give this brother credit. There he is. Okay. We got. Okay. It's gonna go like this. Yeah. So yeah, we'll take Tuesday review. We'll probably kind of do some review on Thursday as well. That'll be week 12. I think it's only 14 weeks. Whenever we break for we're going to be done before we hit Thanksgiving, right? Once we hit Thanksgiving, Morehouse will be done until January. So we'll have taken the final and everything before then. And again, all I'm going to do, I'm just going to base the grade on whatever I see on Pearson. Okay. Again, we get a limited attempt at all assignments. Even if we submit our assignments late, there's only a 10% late penalty. So it's really just a matter of submitting our assignments. So let's continue where we left off last week. We don't have a lot left. It's only like a couple of more topics. We were exploring polynomial long division, synthetic division, and the rational zero test. Let me get rid of this thing. Okay. So I'm noticing the date. That means like Halloween is what, like Saturday. This is so weird. Like I kind of want to ask y'all how have any plans for Halloween, but I don't recommend anybody going around people strangers' doors getting candy that so many people have touched that then you want to take that home and eat it. I'm like, with COVID, I'm like, I don't know how I feel about that. That's scary. That's so scary. But yeah, they kind of did a piece on the Daily Show throughout the night. Just what some places are planning as far as all of that stuff goes. Okay, so continuing with like synthetic division, rational zero test, and polynomial long division. Again, today we're going to look at the rational zero test, right? So say we have a polynomial we just have a polynomial. Let's switch that color to this one. With integer coefficients, and the leading coefficient is not 0, and the constant term is not 0. And P over Q is going to be a rational number in lowest terms that's a 0 of f of x. Then for the P over Q, the P comes from the factors of the constant term. Q comes from the factors of the leading coefficient. So what this ratio of P over Q tells us, if our polynomial has any rational zeros, that rational zero is going to be somewhere in this list generated by this P over Q. Let's see this in action. So we're asked to list all the rational zeros of this. Let me give myself some space, because I usually need space with this one. So I'm going to get rid of this. Okay. I should have did that first, but that's okay. Okay. And the only other thing I like to do is like this. So, okay. So we have this example. We're asked to find all the rational zeros of this polynomial. Okay, so let's start off by doing the rational zero test, right? So the rational zero test, we're going to do P over Q. Again, P comes from the factors of the constant term. So the factors of -3. Okay, I'll have to do it later. The factors of -3 are plus or minus 1 and plus or minus 3. That's it there. And the factors of 2 are plus or minus 1 and plus or minus 2. So what we want to do all combinations with the numbers on top with everything on bottom. All right? So then everything on top divided by 1 is just going to be itself. And then everything on top divided by 2 is going to give us plus or minus a half and plus or minus 3 halves. So what we're saying with this generated list is that if this polynomial has zeros, has rational zeros, it's going to be one of these guys. Okay? Again, if this polynomial has rational zeros, it's going to be somewhere in this list, right? So let's just start making our way through the list. Now, before we just kind of start, crunching these numbers, let's get a sense. Let's use the Descartes rule of signs to get a sense of how many positive zeros and how many negative zeros we can anticipate, right? So another test. Descartes rule of signs, right? So we're gonna just do a quick demo on that, right? So if we count the sign changes in the original, so if we get a copy of the original, this f of x, 2x cubed plus 5x squared minus 4x minus 3. And we count the sign changes. We have one sign change from here to here. There's only one sign change, right? So that means we have one possible positive 0, right? So what that means is that if we find a 0 that's a positive number, that's going to be the only one there is. So we don't have to test any more positive numbers from that point on. Let's test for the negative zeros. So for the negative zeros, we do f of negative x. So first I'm going to replace each x with a blank set of parentheses. Okay. And again, we're replacing x with negative x. Okay. So negative x cubed is going to be negative x times 2 is going to be negative 2x cubed, right? The next one, if we multiply an even number of negatives, it goes positive. So this one stays as 5x squared. Double negative there is positive, minus 3, right? So if we count the sign changes here, we have one sign change there. We have a second sign change here. So we have a total of 2 sign changes. So what this means is that we have 2 possible negative zeros. Okay? So let's take our list of rational zeros. I need both of those guys. I need this one and this. And let's find our zeros. Okay. So let's test one just to see if it's a zero. So now if one is a zero, we're going to do synthetic division to see whether or not it's a zero. So we're going to put one in the chair, and then we take the coefficients of our polynomial, and we got to make sure that every exponent is accounted for. So it goes 3, 2, 1, 0. So the exponents work out properly, so we're good to go there. So then we just take the coefficients. We have 2, 5, -4, and then -3. If we do synthetic division on these, the 2 comes down. 1 times 2 is 2. Vertically, we add. Diagonally, we multiply. So 5 plus 2 is 7. 7 times 1 is 7. Plus -4 is 3. 3, and indeed, we get our remainder of 0. So we just confirmed that 1 is a 0. So if 1 is a 0, since we started with a degree 3 polynomial, at this stage we have a degree 2 polynomial. All right? So if we write out the factors, let me see. So at this stage we have x minus 1 times 2x squared plus 7x plus 3. There's the zeros, yeah, so we're going to set this equal to 0. All right? So now we want to try to factor that trinomial. Okay. I'm going to use the AC method of factoring. We're looking for two numbers that multiply to give us 6 and add to give us 7. That's going to be 1 and 6. All right. So what I'm going to do, I'm going to rewrite this that green 7 as the 1 and the 6, right? So then this x minus 1 comes down. The 2x squared comes down. We said 1 and 6, so I'm going to say plus 1x plus 6x. Okay. And then the 3 comes down. Everything else comes down. Okay, so now we're ready to do factor by grouping. If we look at in other examples, you may have seen me do this with the box method. So this is similar to the box method. It's just an alternative method. So if we look at the first two, this guy and this guy, what do they have in common? They both have x that we can factor out, right? So this is going to leave us with x times, I think it's 2x plus 1 is left over. 2x plus 1 is left over. So the hint is we're looking for another 2x plus 1 in the second part. What can we factor out of the second 2? Is plus 3. Okay. Notice that 3 times 2 is 6. 3 times 1 is 3. So we're okay there. So now both of these terms have what we call common binomial factor, which is they both have the blue thing. So we can factor out the blue thing from both of them. Okay. It's called the common binomial factor. Okay. So then if we factor out the common binomial factor, x minus 1 stays. The 2x plus 1 comes to the front. And we're left with x plus 3. Okay. So this is the fully factored form of the original. So then from here we get the zeros are x equals 1, -1/2, and -3. Okay. So then with this result, we just want to check, we want to check it in the context of the original and make sure that it works. All right, I know there's a good amount of work, but let's make sure that it works. Man, I don't know how this happens. This happens like as soon as we start lecture, I get like super sleepy. I want to go to sleep. I've been like awake all day. I've been fine. Lecture starts and I just can't stop me on that. I'm like, man, I think it's because I'm looking down. I really think that's what it is. Um, all right, let's put in the original. We got 2x cubed, 2x to the power of 3, plus 5x squared, minus 4x, minus 3. Okay. Let me quit. I'm going to call on that function that I just typed in. So now when x is 1, we should get 0. When x is a negative 1/2, we should get 0. When x is negative 3, we should get 0. Okay. Okay, so we confirmed those with the zeros, all right? We confirmed all of those. Okay. And here's a typed version of what we just did. Oh, is that it? I just knew there was another one. I think that was how we factored out the binomial. Okay. So at this stage, so let's start here where the red star is, right? So we did synthetic division, we tested, we confirmed that 1 was one of our zeros. Because we started with a degree 3 polynomial, after we did synthetic division, at that stage, this is called the depressed expression or depressed equation. So since we started at degree 3, this was a degree 2, right? And you see it here. So then we wanted to factor this trinomial, right? So I'm using a technique called the AC method of factoring. Basically, the A times the C gave us 6. So we were looking for two numbers that multiplied to give us 6 and add to give us 7. Those two numbers were 1 and 6. So then with that 1 and 6, we rewrote the 7 as 1x plus 6x, right? And so then what we use a technique called factor by grouping. So we have this purple bar that's factored by grouping. So if we look at the first two, we ask ourselves, what do they have in common? What can we factor out of those two? Well, they both have an x. If we remove an x from here, we're left with 2x. If we remove an x from here, we're left with 1. Okay? And then, so that's where the blue 2x plus 1 comes from. And then automatically, because it's like, okay, I know if this is correct, I'm looking for another 2x plus 1. So I just go ahead and write it off to the side, right? So when I found this one, I went on and just wrote this one. And then I was like, okay, now that I look at the second two, I ask, oh, they have something in common as well. What can I factor out of the second two? Well, if we factor out 3, if we factor out 3 from these two terms, we get this thing here. 3 times 2x plus 1, right? So now, again, terms are things that are added and subtracted. Factors are things that are multiplied and divided. So because of this plus here, we have two terms. Here's the first term, here's the second term. So then we have what's called a common binomial factor. In other words, both of these two terms but they both have the blue thing. So we just factored the blue thing out, and we were left with x plus 3. X plus 3. Okay. All right. Another way of factoring this trinomial, sometimes you'll see me do the box method. Okay. Let me take some time. So I think we finished, that actually closed out 2.3. I want to hop over to Pearson and I just want to check and make sure all of our assignments are available. because I know we're approaching the end. And if you have questions from the homework, now is a good time um, to ask those kind of questions. If you have questions from the homework, so give me a moment to pull up Pearson. Let me go ahead and share a copy of this with you guys. Let me go here, paper. Turn this off. Let me share through a box right here. And this one, the house, this class, into the notes right there. And this is week 11. I must have missed last class. That's okay. Okay. Hop over to Pearson. Let's see. Maybe I can work while that's working. Okay. Okay. I think that loaded. Let me go to Pearson. Ooh. Allow. Allow. Not that one. Okay. Let me see. It's this course. This one. Wow. Wait a minute. Man, this class was so fast. I just knew we had more time than that. I mean, it's the right amount of time. It always catches me off guard. I don't know why. All right. Yeah, I think we go to 3:15. Okay, so that's like about a little over 10 minutes. Okay. So let me see. Exam 1 is there. Exam 2 is there. Exam 3 looks like it's there. Exam 3 looks like it should be open up next Wednesday. You have access for 100% from Wednesday to Saturday. And then after Saturday, there's a 10% late penalty. Right now, we're in week 11. This looks good. We got our homework and quiz. Then next week is the exam. And then after that, we have 2 sections. Man, you blink your eyes, it's going to be over. So next week is exam 3. The week after that, which is week 13, we have section 3.1. So we'll take a couple of days on that. And then, oh, actually, no. In week 13, we're going to do 2 sections. So it might be, we don't have time to do another one today. So on one day we'll do 3.1, another day we'll do 6.4. And then it looks like week 14, that's the final exam. I have it scheduled to open up, yeah, I think that Wednesday of that week. Yeah, and I think that's the last week that we meet. And I think it'll be, it looks like it's available for about 4 days. This says that the last day is November 20th. I kind of need to go and look around and check and make sure that that's the last like week or whatever. But yeah, we're going to be done really quickly. And it looks like our assignments are loaded. Everything looks like it's in order. Okay. If nobody has any burning questions, I think I'm gonna let you guys go. We don't have that much time left. If there aren't any questions, have a good weekend. I'll see you guys on Tuesday. Okay.